Hi everyone, welcome to another YouTube video lecture. Today we're going to talk about um, callback and callback hell. So the concept of callbacks in Python is very important, and it's also important to understand the best practices for managing them effectively. So in this video lecture, we'll dive into the problem of callback hell. So it's called, let me write it here, Callback Hell. And we'll see how what this problem is and how you can deal with it, how you can avoid this problem in Python programming. So first of all, we have already discussed callback in one of the previous video lectures. And callback, as you know, is a function that is passed as an argument to another function, and then it is executed after the completion of that function, right? And I also created a few video lectures where you understand that callbacks are used in event-driven programming as well as asynchronous for asynchronous tasks, right? So let us try to understand how we implement callbacks. I'm going to use a file to help you understand, the creation of callbacks, what callback hell is, and I hope this is, going to help you understand it. Let's see. Okay, so this is a file. This is a file where I'm going to create the code, and I just want you to pay attention to this code, right? And try to understand, like it's a very not very difficult task to avoid callback hell. So let's start with a straightforward example. We'll create a function, and I'm going to call this function maybe do underscore something, right? And so this function takes two arguments, right? And it takes a callback function as an argument, and then it will call it after performing some task, right? So two arguments are data and callback, right? And here, you can write some task maybe, okay? And then maybe we are processing data. So the variable used for that is, let's say, processed data. And you can perform any function in this part. And then we are calling callback using this with this processed data, right? So this is one callback function. Now, what I'm going to do is I'm creating another callback function to because we also need to find the result, and inside this one I'm going to print the result, right? And you can run this program fine. uh, and in this example, as you know, you see that I define do underscore something function. It processes the input data. In this case, the data will be multiplied by 2, and then it calls the provided callback function with the processed data as an argument. And if you run this program, you will get some result, right? So for example, if our value of data is 5, result will be 10, and so on, right? Okay. Now, uh, let's talk about callback hell. So callbacks can be complex, right? If we have a program with callback, it can be hard to read. Okay, specifically now, especially like when the program is heavily nested, and sometimes even callbacks are nested, it can be really complex, right? It can be really hard to read, and this whole thing when it is heavily nested, it is really hard to read. This is called it's called callback hell. Okay. Now let's consider a scenario where we need to perform many asynchronous tasks using callbacks, right? And you will see that as tasks pile up, the code becomes difficult to maintain and understand, right? Again, I'm just trying to take very simple examples so you will understand. So for example, let's say there is task 1 and there is callback, and maybe there is some task 1 implementation, right? And then we are calling callback. Um, then we have task 2, right? And then there is some task 2 implementation, because all these tasks, they will have their own implementation, right? And then let's say I have a task 3, same callback, it's going to have its own implementation, and so on. And then I have this another function, I'm going to call it finish function, and it will print the result, or it will uh, print some value, and it actually shows that um, it's the end of the program, or every task was executed, or maybe every task was completed, right? And then usually, like when we are talking about callbacks, we make use of lambda function. I will also link the video on callbacks in the description or in the end cards. Do check that one if you don't know what I'm talking about. So usually we make use of lambda. So task 2, lambda, task 3, finish, right? Now we are calling like this is nested. This is heavily nested, right? And it looks very complex, right? And in this specific example, we have three tasks, task 1, 2, and 3, each calling the next task as a callback. Okay. And this nesting of callbacks creates a confusing structure, right? Now this is called callback hell. And to avoid callback hell and make our code more maintainable, there are a few practices that we should follow that can help in the management of callbacks. So the very best practice is to use named functions, right? So instead of using lambda functions, or sometimes we also use inline callbacks, it's better to define named functions, right? So if you're using named function, it will make your code more readable. It will be easier to follow for others as well. And even if you are looking at your code after some time, you will easily understand, right? So for example, like in this example, we have, lambda function and everything. So instead of doing that, what you can do after you have, defined all the tasks, instead of using lambda function, you can use named functions for callbacks. What I mean by that, so you can just write, so for task 1, when you're calling task 1, task 2 underscore callback, right? And so for this, now because we are using task 2 underscore callback, you can define this function. So callback, and we are calling finish. Um, not here. We will not call finish here. So because we also need to call task 2. So task 2, it will be task 3 underscore callback, and then we need to define task 3 underscore callback, and we have function finish. Okay, so in this example, in this improved version, I'd rather say, what we did, we defined separate named functions for each callback. Okay, so this actually eliminates the deep nesting and it improves code readability, right? And this is like one way of dealing with it. Another way of dealing with callback hell is to utilize libraries for asynchronous operations. Okay, so as you already know, we discussed asynchronous operations in previous video lectures. Python provides libraries like asyncio and concurrent dot futures for managing asynchronous operations. These libraries have like a cleaner and more organized way. They offer an organized way to handle callbacks and asynchronous tasks also. Okay, so I will try to give you an example. Suppose first, if I'm using async operations, first I need to import asyncio, and again check that previous video lecture to understand how we define these functions. So async def def task one. So this is first function that has been defined, and there will be some task implementation, right? And then await asyncio dot sleep. So we are making it sleep for, let's say, 1 second. And then here you can print some function, like task one completed or something, right? Then um, I'm going to define another task. So maybe task two. And for this one, again, task completed, await async io dot sleep and maybe 2 seconds. And then we will print like, completion, completed, right? And again, maybe I have another task, task three. This is some task. And again, await async io dot sleep for 1 second maybe, right? And for this one also, we will, print something. Maybe, it's been completed or anything like that. And then comes main function. So async def main await async io dot gather. So I'm using gather function. And here we have task one, task two, and task three. And then we're going to print all done or all completed, anything can be printed, right? And in the end, async io dot run and main function, right? So in this example, we are using async io to run the tasks asynchronously using the async and await keywords. I already explained their use in one of the previous video lectures. The gather function here, it groups the tasks and the code becomes more organized without nested callbacks. I didn't have to use any nested callbacks here. Okay, so this is how you can avoid callback hell, and definitely it makes life way easier if you can avoid callback hell. And that's it for this video. I received one request for one of the subscribers asking uh, for a solution to callback hell. So this is the solution. I tried to help you understand callbacks in Python, and how to manage them effectively, avoiding the dreaded callback hell. And obviously by following these few practices, best practices, like using named functions, leveraging libraries for asynchronous operations, you can write very clean, crisp, and maintainable code, making your Python programs more efficient and robust. Thank you for watching. If you found this video helpful, don't forget to like, subscribe, and share it with others. Happy coding. I'll see you next time. Keep your questions coming. uh, Till next video, take care.